Hello everybody and welcome back to the third episode for Tech Talk. I'm here with Mark Edworthy, or Edworthy10, I believe in how you say it.
Yeah.
And Tan is supposed to be coming in, hopefully. He says he's going to try. But on this episode, we were talking about deep learning, and I believe that would be a good topic to go further in. But I also wanted to kind of skim over some of the things that are going in lawsuits against some of these. I guess the term is alt tech platforms. I just now learned about that, so if I freaking say it wrong, Mark, I apologize. So
That's fine. That's okay. Yeah, alternative technology, old tech. Yeah.
So last week I brought up Rumble, and that had to do with the EU, right, or with the UK, and I mentioned a little bit about SEC versus library, and I got an article from Ropes Gray. I've always liked to read their stuff because they always seem to have pretty good information, you know. So I don't know if you agree with me on that, if it's pretty legitimate.
I'm not familiar with Ropes and Gray personally. I think it's the first time I've actually come across the site. But skimming through the article that you linked to, looks to be a fair summary.
So with that being said, the reason why I want to make sure that you agree with it is so that I could, you know, have some kind of verification. If you didn't like it, then we wouldn't use it, you know.
No, I think it looks not overly familiar with the Rumble U.S. Security and Exchange Commission case, but from what I understand, it looks like a fair write-up.
Now, I can read the first paragraph of the one for these, and then, like, right now I just really want to discuss more on the library thing, because that was one that I was able to really go through and look at real good, and then, you know, after we're done there, we can kind of talk about it if you want to, but I'll just read this paragraph real quick and we can start from there. So this is from Ropes and Gray, and actually let me go ahead and put it on the, well, I got it on there, but it's from Ropes and Gray, and it says, on November the 7th, 2022, Judge Paul J. Barbadoro of the United States District Court for the District of New Hampshire granted the Security and Exchange Commission (SEC) motion for summary judgment in its suit against LBRY, which is commonly called Library Inc., or LBRY, a blockchain-based video shared platform. The court held that Library Credit (LBC) coins that Library offered and sold constituted unregistered securities in violation of the registration provision of sections 5A and 5C of the Security Act of 1933. The court also rejected Library's argument that it lacked fair notice of application of U.S. security laws to LBC, even though the SEC's prior enforcement actions in this context had focused principally on tokens characterized by an initial coin offering, ICO, a form of promotion that library did not use. The ruling is significant for the digital asset industry as participants seek to achieve clarity regarding which assets qualify as securities and is sure to be prominently featured going forward in SEC and private litigation, contending that various digital assets are securities, including in the SEC's ongoing litigation against Ripple Labs, or Ripple, before the Southern District of New York. So what did you take from that one, Mark?
As far as I could see, from my previous review, the library just violated, what was this, Section 507, the Regulation D requirement?
Mm-hmm. No, later on they did.
Title 17. Section 204, 230507. Really, library just violated the U.S. Securities and Exchange Commission's rules when it comes to providing information as far as the value of those tokens were concerned.
Mm-hmm. Now, didn't they even go as far as not even register the token with the SEC?
Yeah, that's what I mean. Sorry, that's what. That's what I mean. They violated that regulation, and they should have registered that asset in the first place, and they never actually did.
They never did it.
Mm.
Yeah, like back here, down here on the background, it talks about a little bit of the network's native currency. In 2006, they launched LBC, the network's native currency, which could be deployed on the library blockchain to publish content, tip creators, buy paywall content, and compensate miners that supported the network. Now,
I've got a problem with calling it a currency.
Yeah.
Because it's a token, and under US Securities and Exchange Commission rules, it is not recognized as a financial asset, therefore not a currency.
Mm-hmm.
I suppose you could use the term currency in a very sort of loose context, but yeah, I don't like the calling that a currency.
Well, it says, unlike tokens that launch through ICOs, LBCs were sold directly through the library application, while also being used to compensate employees and incentivize users. Library also reserved 400 million LBC tokens out of a total supply of 1 billion for itself. So it wasn't 80%, it was 400 million LBC tokens.
So they were using those tokens as being generally used as stocks were generally used in the 90s to reward employees.
Yeah, maybe even payments. Hello.
Đang làm hồ bơi. Nói trước thì ông muốn ba đi, ông nói trước để ba chuẩn bị. Giờ đang giữa chừng phải thay đồ.
He's falling asleep. He didn't even get on here for maybe 5 seconds and he was yawning. Did you hear that? Yawning and yawning and yawning.
No, không có lose face, nhưng mà ba sợ cô giáo của Mít la ba thôi.
Oh shit, I don't know what
Mít đâu?
He's speaking tongues.
Yeah.
Hey, you got your video cam off. How are you doing that? Like, Oh, you just have it turned off. But yeah, on here it does mention kind of what you say, like with the incentive, they were incentivizing users. They could be possibly even paying them for their own cryptocurrency too.
Yeah, but again, it's a token and not a cryptocurrency.
Yeah.
I've specified the differences between the two assets in the past.
Now, they said the SEC brought an enforcement action against Library in March 2021, claiming that Library had offered and sold LBC as an unregistered security in violation of Section 5A and 5C. Now, do you know what they mean by unregistered security?
Yeah, I did go over it a couple weeks ago.
Look there.
Again, according to Regulation D, US Title 17 CFR, Section 230 to 507, the tokens need to be registered with the Security and Exchange Commission. Whereas in this case, they were never actually registered.
Okay, so like when they say security, though, what is the basic definition for that when it comes to the SEC?
I want to say any asset, but I'm pretty sure that's actually incorrect. I'm pretty sure that they're using the word security incorrectly. Maybe not. In that case, it would be any asset.
Any asset. Yeah, so basically they're saying that unregistered security, so all their assets needed to be registered. And it wasn't. It was in violation. So the SEC seeks injunctive relief. Now, disgorgement. What the heck is disgorgement? I know you know that one.
Disgorgement. What's I think?
Out of anybody I know you know what disgorgement means.
What are we reading? What are we reading about, guys?
The SEC versus Library.
Okay. Where is it? Did you post that in the chat?
Any remedy. Yeah, any remedy requiring a party profits from illegal or wrongful acts to give up any profits they made due to the illegal or wrongful conduct.
The second link in the chat, Tan.
Alright, I see it.
Yeah.
So that's disgorgement.
So yeah, really to give up the sort of profits that they made due to the act.
And civil penalties. Both the SEC and Library submitted motions for summary judgment. And this is where I find it kind of screwy, okay? Like, and it's not even on the SEC side, it's more on frickin' Library side, where they were honestly trying to say that their members who were part of the Library community didn't want any kind of profit whatsoever. You know what I mean? Like, they just got on there and they were using those coins and they didn't expect any profit whatsoever.
They may have signed a terms of may have signed a contract, terms of service or something, to stated that they weren't eligible to make any profit. They may have. I'm not saying that is the case, but.
Well, this falls back on you again.
So in that case, Library can turn around and say, well, they've signed this agreement, therefore they've agreed, and they didn't want to make a profit.
Yeah, but see, this falls back on you again because I personally know you read Odyssey's freaking term in services, and
I've read a lot of terms of services.
yeah, but you read that and you told me like a lot of information that was good. Like when you read library, you told me that their freaking legal jargon was horrible. It had bad spelling and everything.
Yeah, that was a couple of months ago, wasn't it? I vaguely remember that one. Sam, I think you saw it as well, didn't you?
Yeah, I went through there.
Yeah.
I went through there too. Well, since you've seen it, what do you think, Tan? Do you think they had proper documentation?
Yeah, I'm just trying to catch up on this finding here. Can you help me catch up? So what was the court's ruling that the library's token is actually a currency?
Yeah, they.
No, it's still a token, but yeah, they ruling was that they never registered that token with the SEC. Or at least not registered the amount. And
Okay, LBC coins are not securities. Okay, because they're consumptive in nature.
Yeah, that's what they were trying to say. Yeah, but the SEC finally made the verdict that it was a security. That was the big deal between them.
Right, okay. Oi.
It was pretty interesting. And
what implication does this have on Rumble or
well, we're just talking about library
or Odyssey,
today.
right? Odyssey is the one that's using
separate.
yeah.
Oh, now Odyssey, what happened, I know this from a thing that they posted on their help and support and everything. They broke away from library altogether, and they ended up going into they connected with like groups like Mastodon and all them, so
Yeah.
they got hooked up in that, so they're going that direction, even though they're still using the library tokens. So they said that in their in what they were talking about, that it does have a kind of a ripple effect, a domino effect, but they don't expect it to harm Odyssey in any way. But that could be just, fancy talk. That's what you intelligent people do. You come up with fancy talk.
That's really for lawyers to decide on, or lawyers to argue,
Yeah, but
or judges to decide on.
There's a section in here for implications.
what did you find?
Well, so this is the first time, and I'm just reading. It's the first time that it's ever been ruled that a token is a security without having been offered in ICO. Okay.
No,
So
ICO.
what is
ICO. What
initial
is
coin offering? Right. It's just like in relation to company stocks, right, where they have an initial public offering, an IPO, right?
Right.
Then they offer stocks for sale. In case of digital currencies, they have something equivalent called an ICO. Correct me if I'm wrong, Mark.
No, that's fine.
Yeah.
Okay.
Okay. So library is broke, or Odyssey is broken away from library, so they're not. They're not liable or implicated.
And to be fair, I mean, honestly, I could see them maybe knowing this was coming because like they made it a point for a couple of years now to kind of break themselves away from Odyssey, and now before that they were trying to transfer the old library, which I was on the old library, and they were redirecting me from the library platform to Odyssey and saying, ta-da, this is the new freaking platform, you know. So they were really trying to steer people away from being on library for a while now.
Yeah.
So I could honestly say they knew this was coming.
But what was Odyssey using library for?
That's their mother platform.
Okay.
Odyssey was its own company.
Odyssey was supposed to be their prodigy, their breakthrough, the greatest thing that was ever invented by man. So I found it pretty interesting. I mean, then up here, when they talk about the parties' arguments, okay, they say that the SEC argued that LBC is a security because one, library offered and sold LBC for money and other consideration. Two, the LBC purchasers invested into a common enterprise because library pooled the money raised by LBC sales and used it to fund the development and operation of its platform. And three, a reasonable purchaser of LBC would expect to earn profits derived from the efforts of library. The SEC pointed to the various statements made by library personnel to potential investors in blog posts, emails, and interviews, allegedly suggesting that the value of LBC would appreciate as library networks were further developed. The SEC also emphasized that library designated 3 million per mine LBC tokens for itself, making library the single largest holder of LBC. The SEC argued that library's stake in the LBC coin made unmistakable to LBC purchasers library's financial incentive to develop the library network and thereby increase the long-term value of LBC.
Yeah.
So, no, that's where the problem came. The major problem was because it's a crypto token, it's not a currency, and therefore cannot make it's not financial assets. This goes back to very similar to clause section 17 of the Mines Terms of Service, which I keep on talking about.
Well, so this is what the Security Exchange Commission decided or ruled. Does that mean it's enforceable now, or does library have a chance to appeal, or?
They always have. There's always a chance of appealing, but that I'm not sure that library would do that. As far as I'm aware, they are technically out of business now.
Oh,
are they?
I see.
Maybe.
Are they?
They could be.
I guess one way to get away from this ruling is to declare bankruptcy, I guess.
Bankruptcy in the United States.
But yeah, I know there's still, at least the side's still up.
But how does this affect mines? Like this sounds very similar to the mines token, right? What if the SEC goes to mine and say, "Oh, your token is actually a security"?
I think that's why they're doing the crazy
It's
shit
already,
they're doing
yeah,
now.
it's already, mine's already, as soon as the token created, launched, mine's already, registered it as a security.
Yeah. Now,
What is it?
Because like people, it's available on the Ethereum network for purchase, for selling and buying.
That's Uniswap.
Yeah, and that is the problem. That's the problem. If you followed my question of
well, yeah, you raised the alarm, but like nobody it's being ignored, or is it like is this gonna be like a catastrophe waiting to happen for mines similar to Library?
No.
Well, I can't see the Library issue being a similar issue for mines, because Library, mines registered their token immediately anyway. But I could see a potential violation of or a potential complaint about violating a legal contract, the terms of service contract.
Oh, well, with respect to, are you talking about now the
no, that we've got
abolition of the token reward system?
Yeah, no, that the token is actually being put on Uniswap and MetaMask and those other technical exchanges, and also the liquidity issue. There is a clause, I think it's 17.5.U or W, that says that Mines makes the company makes no representation of liquidity.
Right.
But they do.
Right.
Now, Library argued in support of its motion for summary judgment that LBC coins are not securities because, one, they are consumptive in nature, with purchasers using LBC for on-chain activities rather than investment purposes. Then two, the primary focus of Library's promotional statement and material was the utility of LBC, not its potential price appreciation. And three, Library stated explicitly in marketing materials that LBC was intended for consumption on the Library network, not as an investment. Additionally, Library argued that it did not have fair notice that it was subject to U.S. security laws because the SEC never brought a similar claim against a coin user outside the ICO context. So
because no other because they've not found another token holder that's committed this violation.
Yeah,
that's why they have not. And really, really to say, well, just because we advertised it as this, therefore it isn't. That is meaningless, because false advertising happens all the time.
Yeah,
it happens all the time. Let's say false advertising and or halfway happens quite often.
Now, the thing that I find is I think that's really a weak argument that they brought up to him, and it goes on down here in the bottom too, where they start, wait, no, this is the bottom, but they try to say in one part here where freaking Library even tried to say that the actual community didn't expect a profit to turn out because of their transactions. So these people went on there and paid for premium, and I think they've got like 3 or 4 different paywalls or subscriptions.
Well, it goes back to my argument that if the terms of service says that this isn't a profitable or isn't a financial asset, and the user agrees to that terms of services, and therefore being able to register an account, then libraries can say, well, they've agreed to this terms of services, so they've already agreed that there isn't a profit.
Yeah. And
irrelevant if the user reads the terms of services or not.
Yeah.
What brought about this attack on library?
Well, I personally think that's probably one of the reasons why, especially Minds, you were talking about Minds, I really believe that that's one of the reasons why they're acting the way they are. I think they're either going broke or they're scared shitless. They're even doing the same things that freaking Odyssey did. They're running to Mastodon. They just had a
oh yeah,
they just had a freaking Minds live 2 days ago where they were talking about how great freaking Mastodon was, and they're going to go to the
You're talking about Minds now.
Yeah.
Not Mastodon. The Fediverse.
Well, Fediverse.
Not Mastodon.
Mastodon is a smaller version of Fediverse, right?
No, it's just a player in the metaverse, just like Mind is.
But
it's more of a marketing term, an all-encompassing market.
Their mark goes.
I really wouldn't doubt, though, if that's what it is. They're scared shitless. That's the reason why they're doing all this stuff.
No, as far, like I said, as far as the libraries, excuse me, as far as the library issue is concerned, it has got no, it's not relevant as far as Minds is concerned.
But you don't think that this is a big win for the SEC?
The entire crypto ecosystem, whether that be crypto tokens, currencies, decentralized digital assets or NFTs, is a fairly young sort of industry. You could argue there's sort of the modern Wild West. Regulations need to be formulated and implemented. It's not only an issue with the US, but it's an issue with most countries, territories.
Mm-hmm. I'd really like to dive more into that thing with Rumble too, because like you'll even see it on freaking Minds, and everybody keeps jumping into this shit with what's his face, I forgot his name, shit, about how he had trouble with the law and everything. But that's not the issue. That's not why the UK is going after Rumble. You know what I mean? Like, freaking, they're just targeting him and everything, you know. And all these alternative media sources always jumps on that bandwagon. You know what I mean? But I'd really like.
Oh, you talking about?
Brand.
Yeah, brand.
Yeah.
That's more to do with the so-called online safety bill.
Yeah.
Inverted commas on safety, because it's that's the guise that they use to enforce it, but it's really a means of controlling narratives.
Mm-hmm.
Hence why they've using Ofcom, the UK Office of Communication, to monitor and regulate.
Do you guys see the footnote 9?
Trying to. There we
where
go.
they had gone after Telegram as well.
Telecom?
Telegram,
Oh,
the
Telegram.
messaging.
Oh hell, isn't that a porn site?
No, Telegram is like
No.
a messaging service, just like
Yeah, I mean, like
Signal.
Oh
instant communication.
I know
Yeah.
what you're talking about. That's the one.
Yeah.
Oh god,
Telegram Messenger. Yeah.
Yeah. I remember people off of Tinder used to use freaking Telegram.
Yeah. It's like WhatsApp, right? Or Minds Chat.
Yeah.
It's end-to-end encryption. But so that's interesting, right? So SEC is starting to going after all these different.
And see, that's my argument right there. I'm seriously saying I think this is a witch hunt. The EU and the United States and the UK are all working together, and they're gonna start going after these.
I'm not sure if they're working together.
I don't know. I mean, it just all seems to be happening right around the same area, you know. And on I haven't mentioned it on here. Well, yeah, I did last week, but like Activision with freaking the UK. It seems weird that freaking their stipulation for the EU is that Activision has to freaking put their games on the cloud. You know what I mean? On a cloud.
Oh, really?
service. Yeah.
Wow.
But that's more of a competitions and mergers issue rather than
This is some-
safety stroke.
Is it like Activision is hardly a big name like Microsoft? Why would they be
Activision.
Activision, what are they? I can't remember what they called now.
They make arcade games, right?
yeah.
They are a big
400
game
billion
publisher.
worth of video games.
No.
Activision Blizzard. That's what I was
But-
thinking.
But they started it with the arcade game machines, right? So
Yeah.
what did it have to do with putting their games
Activision,
on the cloud?
Activision
no
as a
clue.
brand has been around since the 70s, I
Yes.
think.
Yes.
Oh, in fact, 79. And I remember picking up games for
Yep.
things like Commodore 64s and
Yep.
PCs.
Atari
the
128 right here.
Yeah.
Yeah. And some Activision
brand and
games
all.
back then.
Yeah, it could be going back to what we were talking about too, about the difference between servers and clouds. And
So it's like it's like an antitrust issue kind of thing,
it could be.
where like they have a monopoly of the arcade game.
They actually tried to bring that up here in the United States, and with Biden, and freaking the courts here shot it down. He actually tried to do the antitrust shit. He was against the merger between Activision and Xbox, just like the UK was. The United States court, they shot that down. I don't know why, because it is huge. It's a huge company. It really is.
Well, yeah, if Activision and Xbox gets merged, they'll be tremendous.
Yeah.
They'll be gigantic. Xbox is Microsoft, right? So
Xbox is actually a subsidiary company, it's not.
yes,
Microsoft.
Yeah.
They got their claws in everything. Now Sony, I heard, was actually the Antichrist. I'm not sure if that's true or not.
Really?
Now,
Who started that?
it was some
what do you call
computer
it?
geek. Some computer geek, and he's sitting around. He thought of Y2K, and then when he had nothing else to do after the Y2K, he said, "You know what? I'm gonna freaking call
He's
Sony
gonna go
the
after
Antichrist."
Sony.
But yeah,
You should discuss that in your conspiracy.
I actually
stream.
I have to build up to that because like we're not to that level yet. You know what I mean? I'm just getting to
Yeah.
MK Ultra.
Okay. Okay. All right, getting this. You have a long list of scheduled plans.
But yeah. So I figured at the beginning we could just kind of go through this one, and then later on we can talk about freaking Ripple. If you guys wanted to do that, I just figured I'd post Ripple's link there. That way, if you guys want to read
Spend
through
40
it.
minutes talking about a library.
Yeah.
So much for the beginning.
Now, I'm gonna post.
So,
huh?
what is it? What is it? It's in here. Ripple is also in here.
Yeah, it's in
So it's
here.
all related.
Well, I mean, do you want to talk about it, or do you want to go on
I
to
don't.
deep learning?
No, I don't know anything about Ripple, man.
Very.
It's up to you guys.
Yeah, I'm not overly familiar with the case.
Yeah.
We were talking about doing deep learning, and I posted the first one for Wikipedia on there. That I'll read the beginning of it and let you guys start up the
All right, we're
conversation.
going to deep learning.
Yeah, deep learning. But let me at least give the first paragraph.
Show it.
Okay, deep learning is a part of a broader family of machine learning methods, which is based on artificial neural networks with representation learning. The adjective deep in deep learning refers to the use of multiple layers in the network. Methods used can be either supervised, semi-supervised, or unsupervised. Deep learning architectures such as deep neural networks, deep belief networks, deep reinforcement learning, recurrent neural networks, convolutional neural networks, and transformers have been applied to fields including computer vision, speech recognition, natural language processing, machine translation, bioinformatic, drug design, medical image analysis, climate science, material inspection, and board game programs where they have produced results comparable to, and in some cases surpassing, human expert performance. Artificial neural networks, ANNs, were inspired by information processing and distributed communication nodes in biological systems. ANNs have various differences from biological brains. Significantly, artificial neural networks tend to be static and symbolic, while the biological brain of most living organisms is dynamic, plastic, and analog. That was a mouthful.
That's a mouthful of technical jargon. I'm not sure we understood.
Even I'm a bit confused over that one.
That was
basically, deep learning is a subset of machine learning, right?
Right.
And machine learning is about teaching the computer how to do things. And at the very basic level, there's algorithm. Even before machine learning, we had computer programs, which are basically an algorithm that tells the computer, gives the computer instruction how to do things. That's the very first basic level, right? But then we have artificial intelligence as an area of computer science is developed. They've taken that to a new level where they're trying to teach the machine to instead of static programs where you give a specific, basically a program is a bunch of conditional, right? If this happened, then do this. If something else happened, then do something else. Things like that. It's a static list of instructions to tell the computer to do something. That's the program. But with the self-learning program, which is what AI is trying to do, is to have a program that is able to adapt and learn, gain new knowledge based on the data that's being fed. And so that's part of machine learning. And so now we have, part of machine learning is they're developing computer models that mimic the brain. That's why they call it the neural network, right? So they have this computer model that has a bunch of layers of nodes that you pass the data through, and each of the nodes is like a learning function that compute the data and gives a result, and then it gives a guess of what the outcome is. And if it gets it wrong, you feed new data to it, and it relearns, it corrects itself on the next iteration, and eventually if you iterate that over a large amount of data, it will correct itself, and eventually it gets the right answer. So that's basically, and then deep learning then is you have a neural network which has many layers, deep number of layers that you pass the data through to the end to get to train, like basically a model. You pass the data through to train it, and the more number of layers you have, the better accuracy you have of the model being able to adapt.
Now you're discussing the artificial neural networks, right?
It's inherent with deep learning. Deep learning is you work with neural network.
Yeah. Like right here, it says that the artificial neural network, they are a branch of machine learning modules that are built using principles of neural organization discovered by connectionism in the biological network. Neural networks constituting animal brains. So it's basically reproducing the human brain.
Yeah,
that's insane.
I'm not sure if it's. I feel uneasy to call it reproducing the brain. I would say reproducing thought processors rather than.
Yeah, it's like it simulates the brain. It simulates the behavior, the functions of the brain.
Now, the representation learning is what they have after that, and that kind of like goes into what you guys just said. It says the machine learning feature learning or representation learning is a set of techniques that allow a system to automatically discover the representations needed for feature detection and classification from raw data. This replaces manual feature engineering and allows it says something else, but I can click on the link if you guys want me to. But that's what I get from it. It's it detects freaking representations. You know what I mean?
Yeah, it's like image recognition is one of the applications of it, right? Be able to recognize images and tell whether it's a person. First of all, whether it's a human or an animal, and then when it's a human, whether it's Roger Hansen or Mark Edward, and not be able to make the mistake of of identifying one for the other, right? So, also, you know, it's the very basic example of this machine learning is the chess program, right?
That's, being honest, that's the first thing that came to my mind. What was the name of that? It was Down the Rabbit Hole. There's an awesome video out where they explain how the guy who came out with the artificial intelligence for chess playing, he actually had his computer program go up against the world champion in chess.
Which one? Garry Kasparov?
He was the Russian guy.
Kasparov, right?
Maybe. I don't know. You're the chess.
I suppose this is during the Soviet Union era.
Yeah.
Back in the 80s, possibly.
The name of the video is called Down the Rabbit Hole. It's probably one of the best.
Send it in the chat.
That's what I'm gonna do.
Sounds familiar, but I don't think I've watched it.
Down the rabbit hole. Oh boy, I guarantee you this video is probably getting down the rabbit hole video. Down the rabbit hole chess.
Where are you sending this, man? You just send the link. You don't have to tell a story about it. where are you shooting this?
Alright, down the rabbit hole. Oh man, they aren't. I can't find the freaking. It was a huge.
Oh, I see.
document.
You're searching it. Are you searching for it? Okay.
It was actually. This might be it. I want to make sure that the audio's off. So.
All right.
Yeah, here we go. Here's a good. Here it is. This is exactly what I was talking about. I was thinking of. Now the actual video, it goes through and it really discusses like everything that they had to learn from it, and they're showing you like bits and pieces of the people who created
Deep Blue,
who created
the
computer
IBM
system.
supercomputer.
Yeah. I'm not going to turn it on or nothing. It's just it's a pretty amazing documentary. Basically, it explains the whole thing behind chess. And whenever I watched that video and I was reading that was the first thing that crossed my mind. I wonder if maybe people who were involved in that eventually got better at what they were doing, because like when this all started, college students didn't make money off this. They actually, most of the guys who were involved in doing that program ended up broke with no money to their names. And they were so obsessed with frickin' trying to make an artificial intelligence that could play chess, and not only play chess but beat humans. So
Interesting.
yeah, it's pretty interesting. That did stick in my mind whenever I read that. No, just so
Send
I
the
don't.
link. Send the link in the
Didn't
chat
I already
room
do
so
that?
we could know.
See, I got excited. I need to stop doing that.
Right. It's okay. It's good to be excited.
This is actually this is quality stuff right here. Being honest, it really is. Whoever put this together did a really good job of it.
And it's just 2 years ago.
I gotta give him credit. He did a real good job. I just posted it. And that could be off of an original video that maybe he got that from. I don't know. But this is the guy that I ended up.
You haven't seen it. Oh, there you go. Where did you post it?
The link is in
Oh,
the chat.
oh, don't put in your chat room. Don't put on the just.
Oh, I can do it in the chat room too.
Because the meeting is gonna be gone, and we're gonna have no history of the chat, right?
No, John wants me to try Daily Motion.
Okay.
I have no idea what Daily Motion.
So many platforms. It's a video platform, just like YouTube.
Now,
Yeah.
on that Deep Motion too, the thing they were going over with supervised learning and the semi-supervised and unsupervised. Now, there's some things I did recognize there, like first of all, they're talking about models, and like in science, I understand the concept of the models, but the one things, or the couple things that did stick out to me was they were talking about algorithm, like the algorithms, and they talk about paradigms, and
those are all computing terminologies.
well,
they're all algorithm, like the deep learning algorithms. They have.
let's start from the beginning. Let's talk about paradigms, Dan. What's a paradigm?
Mark, maybe you should go.
It's a business.
Yeah, I think paradigm is like a business term.
It's just really a word meaning an example or pattern of something.
It's a way of doing things, isn't it? It's a paradigm.
It's just really sort of what's the easy way? It's really just another synonym for a a pattern.
A set of concepts or thought patterns. You're right. Or including theories, methods, postulations. The paradigm. So we often hear of paradigm shift. Like when you have something new coming out that's going to change the way we're doing things. That's a paradigm shift. It's like a new way of doing things. So
as an example, when we moved over from I don't know classic mobile phones back in the early 2000s to smartphones, that was a paradigm shift.
Like from the BlackBerry to the iPhone.
Now, paradigms. Then you wouldn't say that it would have anything to do with a shift in logic when it comes to the program. Like it would be able to actually think for itself and make a judgment call at a moment's notice.
Well, yeah, you have a good point there. I mean, like having the computer program being able to learn by itself is a paradigm shift in computer programming. Right. So what you have before, just a static program with a bunch, like I said, a bunch of if conditionals. If this happens, then do this. If otherwise, this. Now this is with artificial intelligence and deep learning, the program is able to evolve and learn as it gets fed more data. It's like think about ChatGPT, where it has access to a huge amount of data, and it can use reasoning or natural language reasoning to give you a clear answers to your questions like that. I lost my train of thought. What I was gonna say.
Paradigms. You were reading that documentary, weren't you?
Which one?
The one that I have up on the screen.
The YouTube. I haven't watched it yet. I'll probably watch it later.
I'll pull that down so that it doesn't distract you. Now, the thing that I was getting from that was, well, the paradigm, and then it starts talking about algorithms too, you know. Everybody hears about algorithms now, especially YouTubers, you know, and trying to get that perfect algorithm for SEO and shit. But I'm pretty sure that's not what algorithms are about, just in general, because I know, like, back before people were hip on the internet, algorithms were also used for music. They're used for a lot of different things, you know what I'm saying? So is there any way that you two, one of you, could kind of give a brief explanation for what an algorithm is, just in general?
It's an algorithm, without looking into the technical definition, is just a way of solving a problem. It's an algorithm is a systematic way of solving a problem. So in computer science or mathematics, or in computer science, when you approach at the problem and you're trying to find a solution, you don't go straight to code and you start cranking up code. You start expressing, expressing the solution in general terms, like with some basic keywords, and those are all called algorithms. For example, how do I add the sum of 1 to 10? Right? You start with 1 and you increment 1 until you get to 10, and every iteration you add that to, so that kind of thing, right? What I'm describing is an algorithm, a way of solving a problem in human term. Now you take that algorithm and you convert it to code, then that becomes a program. But the program is not the algorithm. The program is an implementation of an algorithm. So do you get the gist of what an algorithm is now? It's basically a general, a descriptive solution, or a descriptive procedure of how to solve a problem.
Okay, so paradigm, then you got the algorithm. The algorithm freaking solves the problem, basically. And now, I mean, could it be possible that a paradigm could be referring to the algorithms trying to solve the problem when they think that they've found the solution, then it switches to a different paradigm? Could that be what they're talking about too?
Yeah, maybe. Mark, you're the English guy. Maybe you can speak to the language.
I've got to think about that one. The algorithm is a method of solving the problem. It's not.
Yeah.
The
So it's like that. So you have a normal way of solving a problem, and then suddenly somebody comes. So that is a paradigm, right? Like a conventional method or a known method of solving problems, and then suddenly somebody comes and somebody arrives and come up with a new and novel way of solving this thing. Just like Elon Musk. Think about Elon Musk coming into the automotive industry and start building electric cars. That's a paradigm shift from gasoline engine to electric engine. So how do they solve the mobility problem? Okay, you put gas in the car and you start it up and you go from A to B. Elon Musk says, no, you don't use car. I'm going to charge my car. And so that's a
paradigm.
Yeah, it's a paradigm shift.
All right,
At
so
least that's my understanding. I could be totally.
Yeah, that makes sense. Yeah, that's.
I could totally be blowing smokes to you guys, but
No, that's logical, sort of.
so now this is actually where we do need Mark, because
Yeah.
what's this thing about large language models? It says here that we need large language models in order for this stuff to work. For the semi-supervised, so the semi-supervised learning. It is a paradigm in machine learning, the relevant and notability of which increases with the advent of large language models due to large amounts of data required to train them. Now, what do you think they're talking about there? I know you'd know about language models.
So it's just a large amount of data, data sets.
language model. Are we talking about machine learning to recognize natural language, or machine learning in general? It doesn't seem to apply to machine learning in general.
Yeah.
They have machine learning models, but not language models. So probably language model applies to the problem of machine learning trying to understand natural language, right? To be able to read a paragraph and like Chat GPT, being able to read a paragraph and be able to interpret you or retell for you in its own word what that essay means.
Still using the same sentence structure as is recognizable.
Yeah. So in that context, the language model is the model that describes how the computer would go about understanding or recognizing a particular natural language. So natural language is, as opposed to computer language, right, is the language that we humans use to communicate. And it has different syntax and grammars than computer language, right? But so that's why it needs a model to teach the computer to recognize and make sense of the language that it's hearing. So it's all part of. So natural language recognition is part of artificial intelligence.
Now, I could be wrong about it too, but I mean, you mentioned computer language too. Now, what if? Now, could I be wrong? But would that possibly be a part of the whole setup too? Because you'd have to be able to teach the computer how to translate our language into computer language.
Yes, exactly. Well, no, not only that, but not that, but the natural language models will describe how it will recognize the English, for example, and French separately, and when you combine the two models, you'll be able to translate the spoken words of English into French. So the application will be like an interpreter, right? Like a real-time interpreter that will just listen to your verbal and translate on the fly into the native language.
That's some cool stuff, man. I mean,
as well as all the pronunciation sort of rules, so all the grammar rules, so things like commas and full stops, which can change from different language, from language to language.
Yeah, cool stuff. I saw that you posted some Coursera course on the chat room, Roger. There's also MIT has a whole load of open courseware that they offer for free, like postgraduate levels. in artificial intelligence and machine learning and deep learning.
I think also IBM does, and Microsoft has got
I'll post it. I'll find a link.
Section on deep learning. And no, I'm pretty sure IBM has an entire library of resources.
Here, introduction to machine learning. It just comes up just like that.
No, they also had something in here, this deep belief network. It says, in machine learning, a deep belief network, DBN, is a generative graphic model, or alternatively, a class of deep neural networks, or a class of deep neural network composed of multiple layers of latent variables with connections between the layers, but not between units within each layer. So, these variables, latent variables, what exactly are they talking about there when they say latent variables? What could that possibly mean?
Yeah, I'm not familiar with this deep belief network thing.
That threw me off. I was like, what are they talking about, latent variables? Because now, you know, they're talking about paradigms, and then, you know, they're talking about algorithms, and now all of a sudden we've got variables.
Well, they're all, a model has a bunch of variables that you input, and then it's like a function.
Like a function.
A neural network is like a network of functions that compute your input and give you some output, right? So there are variables everywhere. Now, what does latent variable mean? I'm sure they explain it somewhere in that document.
It's probably down in farther down. You know, I could read more if you guys want me to.
But I'm still trying to understand why they call it belief network.
Yeah. Deep belief network.
What does it have to do with belief?
Yeah.
It seems like trying to teach the computer how to have faith.
Have a belief system, maybe.
Which is
this goes into a really sort of. This goes into a weird sort of bizarre sort of argument about sentience. Philosophers sort of this could turn into a very messy sort of.
Okay, so there are two types of variables: latent and observable variables. So latent variable is basically just hidden variables. That's all it means.
Okay. So these are hidden variables, and now what was the other one again?
Observable.
Now what's the difference? What's an observable?
Latent variables are variables that can only be inferred indirectly through the mathematical model from other observables. Variables are, of course, variables that can be directly observed or measured, right? So they're measurable. So that's the important thing. So latent variables, like, you cannot measure them, but they change as a result of some other variables changing.
That's really deep. Now,
it's just getting deep into the technical jargons of machine learning.
That's pretty deep. I mean, that really is. Like,
it has different connotations or applications in different fields. For example, in medicine, latent variable methodology is used in many branches of medicine. Class of problems that naturally lend themselves to latent variables approaches are longitudinal studies where time scales, for example, age of participant or time since the study baseline, is not synchronized with the trait being studied. For such studies, an unobserved time scale that is synchronized with the trait being studied can be modeled as a transformation of the observed time scale. So, right, basically what I explained before. So, latent variable is it's modeled as a result of observing the observable variables. So something changed in the observable variables that caused the change in the latent variable. But what does that have to do with machine learning? Back here.
It sounds like to me that it's like using the observable variables and then it's keeping the results for that as the freaking
yeah,
it's the hidden variables, and it would sound like that, or it's
so the neural network has multiple layers, right? And then there's the visible layers, and then there's these hidden layers that are called the latent layers. Those are the layers that contains unobservable variables that get changed. But why would you care about, like, how can you, like, it's just like cosmology, man, where you, like, you don't know that the black hole is there, but you can tell that it's there by the fact of its effect on its environment, right? Like you have everything flowing into that one point all of a sudden, so you know, oh, that's the black hole right there. So this is kind of a similar kind of thing.
Are you sort of showing those cats sort of thing? You know that the cat is in the box, but you don't know if it's alive or dead.
That is so weird.
Yeah.
Now, I know that this stuff is honestly getting me to think about what I asked you guys last week when I was joking around, but I mean, now that I'm reading this stuff, what was that again? The computer. What was it? I was joking around at the end of the video, and I asked both of you if you think they exist. You remember that?
Oh, I think what exists? I'm trying to remember.
That was over a week ago. That was a long time ago.
I forgot. But that's kind of what.
I mean, do aliens exist, or what were we talking about?
Unicorns.
Unicorns.
It was the something computer. Everybody.
Oh, you mean like
I forgot it. It was
it's computer, that quantum computers.
Quantum
mean, right?
computers.
Yeah.
Oh yeah. The sort of idea that both states can exist at the same time.
Google is working to develop the quantum computer, aren't they?
Google, IBM, Microsoft. For the last couple of years, Chris Barnett, some of the videos, I'll post content based on these videos. For the last couple of years, he's been doing a sort of annual review of quantum computing technology. Been creating posts out for them. IBM, Microsoft. There's a whole load of companies that are
Google, possibly Amazon as well.
Yeah.
But yes, quantum computing has been a field of research in computer science for the past few years.
I think I heard they said they got like 2 or 3 layers already that they've already been able to break through, but it's all environmental. Like they can tell a little bit more about the weather.
Really?
But,
Curious how it's hard to imagine, right? To develop to come up with the quantum chip that it boggles the mind how you can do this, right? It's like we're going beyond three-dimensional and you go into the fourth dimension,
so
kind of a thing.
I've got another question then. How close is the quantum computer to the old television series Quantum Leap?
Well, Quantum Leap is a classic story about time travel, isn't it? It's
Yes.
nothing.
Nothing to do with quantum, is it?
Quantum just means time, isn't it?
And plus, he travels from one body to the next.
Oh yeah, that is weird. I mean, to be able to travel back and forth in time, but then how do you like materialize in the past as into another body? It's just
I mean, you seen the
That's
glowing
like-
light, didn't you? Like whenever he did it, there was a glowing light with a little bit of electricity coming off of him.
yeah. It's like it's that show's got a bit of time travel and like transmutation, right? It built into it. Like you like it's like the Buddhism's transmutation or something like that, where you transmutate into another body. Let me see. Let me see how far they've gone with the quantum computer, right?
Now on the website for IBM, since Mark brought it up, it says, "What is deep learning?" And this is from IBM. It says, "Deep learning is a subset of machine learning, which is essential in neural networks with 3 or more layers. These neural networks attempt to simulate the behavior of the human brain, albeit far from matching its ability, allowing it to learn from large amounts of data. While a neural network with a single layer can still make approximate predictions, additional hidden layers can help to optimize and define and refine for accuracy. Deep learning drivers many artificial intelligence AI applications and services that improve automation, performing analytical and physical tasks within human intervention. Deep learning technology lies behind everyday products and services such as digital assistants, voice-enabled TV remotes, and credit card fraud detection, as well as emerging technologies such as self-driving cars." And that's what
Okay.
Kent was talking
Okay.
about.
Roger, pause that for a second, and I just sent you the link to YouTube there. Let's bring it up and watch it together.
Okay.
It's about Google claiming that they have achieved quantum supremacy once again.
Oh, shit. This can't be good. Quantum. Is it? So this is on.
Let's watch that, and then we can discuss what quantum supremacy is.
So this is the one that Mark posted, or he?
No, just separate.
Oh, yours is in the chat
One on
room.
YouTube. Yeah.
It's more. Mine is more a general sort of review rather than a Google specific.
All right. So I've got it started. Now, do you
Okay,
wanna watch it
What?
on here?
Let's watch it together. Well, how do we? Yeah, share it on the your Jitsi.
Okay. So if we get in trouble for copyright laws, it's Tan's fault. Thanks, Tan.
It's fair use, man. What does it have to do with copyright law?
He's such a rebel.
It's fair use.
Is it? Let me see. I don't see no fair. Yeah, it is. It's got download on it. That's cool. I'm glad to see somebody did that. That's actually pretty cool. I'm impressed.
Where is it, man? Where is it?
I'm getting ready. Give me time. Give me time.
Please wait for this to go.
Google's quantum computer, Sycamore, did something that's going to break your brain. Once again, it achieved quantum supremacy by performing a calculation within a few seconds that Frontier, the most powerful supercomputer in the world, would take 47 years to complete. This is something similar to what Google did in 2019 with 53 qubits. But this time, Sycamore performed the task with 70 qubits. Qubits are the quantum equivalents of classical bits that can represent 1 or 0, or both at the same time, potentially allowing for certain calculations to be performed at astonishing speeds. Quantum computers are still in their early stages of development, but the progress that Google has made with Sycamore is a major step forward for quantum computing. It shows that these machines are becoming more powerful and capable, and it suggests that they could soon be used to solve real-world problems. To get regular technological updates, follow The Secrets of the Universe.
Now you know that they're transhumanists, right? Like freaking Google wants to freaking turn all of us into cyborgs and shit. So, but you guys are still muted, by the way. It automatically mutes you. You know that, right? Like you gotta unmute.
Can you hear me? Can you hear me?
Yeah, I can hear you.
Oh crap! Yes. You
know,
see my mouth moving, but
no,
I didn't realize the mute crosshair in the microphone was so tiny.
Mark said, "To hell with it. I'm leaving it muted."
Mark, you're still muted. I'm pressing the microphone one time.
He's got it.
I just realised I was mute. Okay.
Like
that's cool. That's cool. That's
just hearing that is scary, man. Because
it's actually a nice idea. Like when you play a video, you want everybody to listen.
But I mean, Google. What we just heard there. Google did that. You know they're transhumanists, right?
Right. They did this before, and I think they just done it again. So you were asking before whether they have built a quantum computer. It looks like they did, but just in the lab environment. They've already developed the qubits.
No, I've seen short videos where college students and college professors discussed it, and they said that they have made progress, but
one second.
I suggest you have a look at that 2023 review that I posted a reference to. It's a bit of a long one, actually. It's about 10 minutes long, 15 minutes long. But it does actually provide information about what these companies are doing at this present moment.
Let me see if this one's open source. It has the download thing, but I'm kind of getting nervous.
No, it's not. Creative Commons is under YouTube's own license.
Oh.
Right.
So I can play it, but I'll just keep it muted.
We're playing something else?
I can't see. I don't see. It's for educational purposes, and I know Chris Barron, the person who created it, is an educationalist himself, so I can't see any copyright issues on that one.
Alright, let me go ahead and do it. I'll take my chance because now Mark says
says it's okay.
You guys are gonna get me into so much trouble, I swear.
What are we watching, guys?
I am getting the video. So
the one that Mark sent, okay.
That Mark sent us. So this one's 15 minutes. So we are going to freaking have a time to get a smoke break in.
Wow. Am I gonna watch it?
Yeah.
The whole point of this is watching
I've
and discuss.
quite a few times already.
Maybe.
So suppose how I add all the references on.
That's not fair. How is it that Mark can still talk, but I got muted automatically?
I can hear you, man.
Welcome to another video from explainingcomputers.com. This time, it's my 7th annual update on developments in quantum computing. Quantum computers process data using quantum bits or qubits, and due to a quantum phenomena called superposition, a qubit can assume a value of 1 and 0 simultaneously. In turn, a qubit can represent a far wider range of data values than a classical bit. Always, when I make one of these updates, there are some people in the comments who say things like, quantum computing is a fantasy that, like nuclear fusion, will always be 40 years away. And so, in this update, right? I thought I'd stress two key points right at the start. Firstly, while for decades quantum computing was an elusive dream, in the past few years things have dramatically changed. Indeed, there are now a number of companies, including IBM and Google, which have got working, if experimental, quantum computers. Several of these pioneers also offer cloud access or quantum computing as a service. And indeed, online access to quantum hardware is now available from the two largest cloud computing providers, namely Microsoft Azure and Amazon Web Services, both of whom have partnered with quantum hardware pioneers. So, for example, here is the price list for the Amazon Bracket quantum computing service, which allows researchers to experiment with quantum processing units, or QPUs, from IonQ, OQC, Qera and Rigetti. And already, companies are using Amazon Bracket to develop solutions to real-world problems. As I hope all of this demonstrates, quantum is already part of the computing industry, if in an early and experimental phase. Or I guess you could decide to believe that all of these companies are telling us lies. Although personally, I don't think that's the case. I do believe that all of these companies have got working quantum computers. As a second key point, it's critical to understand that quantum computers are being developed to allow us to do new things in new ways, not old things in new ways. And indeed, I'm not aware of any credible researcher who believes that quantum computers will replace classical computers. Rather, quantum computers will allow us to run new kinds of application, the most fundamental of which is simulating the natural world, which is itself quantum mechanical. So, if we want to run molecular and other simulations which will allow us to improve our understanding of chemistry, physics and biology, and in turn our practice of materials science, engineering and healthcare, then we need quantum computers. Or, as Microsoft reminds us, throughout history it's been advancements in materials that have shaped human progress. And in this context, quantum computers may lead us into a new age by accelerating the discovery of new materials. What all of this means is that if you're interested in quantum computing as a technology that may revolutionize video games, then at least for the foreseeable future you're going to be disappointed. But if you're interested in quantum as a radical computing frontier, then these are very exciting, very innovative times. And this is what the rest of this update is all about.
Is that guy from Microsoft or what?
As we've just noted, quantum computers are no longer a fantasy, with some current machines now boasting hundreds of qubits. For example, in November 2022, IBM announced its new 433 qubit Osprey processor, with the company maintaining its goal of delivering a system with over 4,000 qubits by 2025. D-Wave Systems also already have a quantum computer called Advantage with over 5,000 qubits. However, this is based on a technology called quantum annealing that provides more limited control than IBM's gate-based hardware. future commercial quantum computers will need orders of magnitude more qubits than available in current systems, and for these qubits to deliver error-free results. This is a major challenge, as all of today's quantum computers are based on qubits that are highly susceptible to noise from the environment or component imperfections. This makes the qubits highly prone to error, and the problem only gets worse the more qubits are involved. To give you a feel of the problem, in February 2023, Google stated that the error rates of the qubits on our third generation Sycamore processor are typically between 1 in 10,000 to 1 in 100. The problem was succinctly expressed in this 2018 paper by John Preskill. In this seminal presentation, he coined the term Noisy Intermediate Scale Quantum, or NISQ, to describe quantum computers with 50 to a few hundred qubits and imperfect qubit control due to noise. As John predicted 5 years ago, today's NISQ systems may be able to perform tasks which surpass the capabilities of today's classical digital computers, but noise in quantum gates will limit the size of quantum circuits that can be executed reliably. NISQ devices will be useful tools for exploring many-body quantum physics and may have other useful applications. But quantum technologists should continue to strive for more accurate quantum gates and, eventually, fully fault-tolerant quantum computing. To move beyond NISQ, quantum pioneers have various options. These include refining the application of existing qubit technologies, improving quantum error correction, and developing new qubit technologies. And over the past 12 months, progress has been reached in all three of these areas. For example, in June 2023, an IBM team reported the measurement of accurate results from a noisy 127-qubit quantum computer. This they achieved by making advances in the coherence and calibration of its processor, as well as their ability to controllably manipulate noise. A few months earlier, a Google team also revealed progress in quantum error correction. This attempts to reduce the impact of noise by encoding information across multiple physical qubits to form a logical qubit with a lower error rate. Or, as Google explained, quantum error correction trades many good qubits for one excellent one. As reported in February 2023, Google's experiment demonstrated that the more physical qubits are combined into a logical qubit, the lower the error rate. There are many ways to create a quantum state of matter that may be used for computation. One of the most common approaches is to manufacture superconducting qubits, with, for example, IBM creating transmon qubits using the superconducting materials niobium and aluminium patterned on a silicon substrate. Another common approach is to create trapped ion qubits, with, for example, iron Q using ionized diterbium atoms in its quantum hardware. Meanwhile, photonic qubits may be created by squeezing laser light using ring resonators. As detailed in my 2021 update, this technique is being pioneered by Xanadu and others and may allow the development of quantum hardware that does not need to be supercooled. Yet another alternative is to create silicon spin qubits in quantum dots. As I reported in last year's update, this is being worked on by Intel and may allow large-scale quantum processors to be made using standard microprocessor fabrication techniques. In June 2023, Intel released a new 12-qubit quantum research silicon chip called Tunnel Falls. This is being made available to universities and federal labs who lack the fabrication facilities to create their own test hardware. As Jim Clark, Intel's director of quantum hardware, explained, Tunnel Falls is Intel's most advanced silicon spin qubit chip to date and draws upon the company's decades of transistor design and manufacturing expertise. The release of a new chip is the next step in Intel's long-term strategy to build a full-stack commercial quantum computing system. While there are still fundamental questions and challenges that must be solved along the path to a fault-tolerant quantum computer, the academic community can now explore this technology and accelerate research development. Two other technologies that have received much attention in the past 12 months are neutral atom qubits and topological qubits based on Majorana zero modes. The first of these is being developed by several companies that include atom computing and utilizes the nuclear spin of neutral atoms. To create neutral atom qubits, strong magnetic fields and lasers slow strontium atoms in a vacuum chamber to an almost complete stop. As atom computing further explained, because neutral atoms lack electric charge and are not subject to electrostatic forces, they can be tightly packed into a computational array of qubits. Lasers hold the atomic qubits in position and manipulate them to perform quantum computations wirelessly with pulses of light. At only microns apart, this arrangement of individually trapped atoms allows for massive scalability. Sources of error, such as environmental conditions and laser noise, can be measured and minimized through diligent engineering efforts. With neutral atoms, there are no fundamental physics obstacles to achieving sufficiently high fidelity to enable fault tolerance at scale. Also banking on an alternative technology to deliver large-scale fault-tolerant quantum computers are Microsoft. Since the late 1990s, the company has been investing in many different research teams, each working on different kinds of qubit. Back in March 2022, Microsoft reported that it had demonstrated the physics necessary to create so-termed topological qubits. This was an extraordinary achievement, as whilst the topological Welcome to another video from explainingcomputers.com. This time it's my 7th annual update on developments in quantum computing. Quantum computers process data using quantum bits or qubits, and due to a quantum phenomena called superposition, a qubit can assume a value of 1 and 0 simultaneously to create so-termed topological qubits. This was an extraordinary achievement, as whilst the topological phase of matter has been hypothesized since 1937, it had never before been unambiguously produced in the real world. But Microsoft...
Hello. Hello.
Are you back?
Yeah, I ended up getting shut off. Got kicked out of Jitsi. They said enough of your shit. So.
You got kicked out of Jitsi?
Huh?
You got kicked out of Jitsi?
Yeah, I just literally was put into a Jitsi thing by myself while you guys were watching that video.
You got kicked out into a breakout room. You had to go join back?
Yep. It's crazy.
Oh, that's because of your timeout. You and you're going.
Well, it was fine anyhow, cause I mean, we got good stuff covered there.
Yeah, it's good stuff.
Now,
when you post this video, make a reference to that URL I gave.
The URL.
The Minds URL.
Oh yeah. That's one thing I definitely want to do.
Mark even wrote up on the state of quantum computing. Cool.
I'm gonna post that. I just had to use the YouTube one so that we could play it on here.
Yeah.
Freaking.
I've included all the references that appear in the video.
We got that right there. I just posted it.
Lots of references there. Wow.
Man, people are gonna. Robot came in, man. He started freaking seeing all the posts we got. He got curious.
Yeah, he came in. He saw all those. All of us went to sleep and just let the computer talk.
He got scared, is what it was. They were talking sophisticated talk, and he's like, "Oh hell
no, man! I think this is kind of stuff that he'd be into." But
I'm just picking on him.
Yeah.
You if they have done exactly what they're talking about, that's a big breakthrough, because I remember them talking about those errors, and they were talking about levels of quantum computing in that video. And I remember hearing a little bit about that. I can't remember what it was from the video, but I believe they said they could only do two layers of error-free levels when it came to computing. And that was, I know it had to have been like 5 years ago since I've seen it. One of the guys in the universities was giving a lecture about it. I found it pretty interesting, to be honest with you. So I'm wondering what it is. Maybe they're able to freaking control the weather now.
Control the weather.
Yeah.
Yeah, it's this quantum computer thing sure needs some wrapping your heads around. Well, how do you have a computer bit that is both on and off at the same time? Right?
Well, I like how he mentioned it, that like a lot of people will get the wrong idea of thinking that like quantum computers are going to replace regular computers, and that's like not going to happen. Like, they're not going to have it to where you can freaking connect like a regular computer up to a quantum computer and do crazy shit. Well, actually, I think they have that.
That'd be the application. But, you want to have a quantum computer on your desk at, in your office or at home.
Maybe, you know, we never know. I mean, technologies move very quickly. Before we had the
but what's the application? What would be the general end user application for such?
Well, you can go to Reno and freaking win big on the freaking slots.
Yeah, you can break all kinds of codes, like hack all kinds of security systems in no time.
Again, what's the point? What's the purpose of a general end user?
You can predict the sunspots that's coming off the sun, so that you can determine when the next freaking blackout's going to occur.
I was thinking that it could make your dinner for you.
No.
The average end user isn't going to use that as part of their general day-to-day sort of office, or
maybe gamers, right? For game engines where it needs intensive computing powers right now that are using FPUs, maybe they'll need to use QPUs, quantum processing unit.
I could see that happening, but I mean, being honest though, the guy's right. It's not going to happen anytime soon. Like, we're going to be dead and gone when that shit comes along. Like, 2085.
Well, I think it could happen quicker than that, Roger. Because I remember way back when I was in university and they have a research lab in mobile computing. And I was thinking, what's mobile? Who's gonna use this mobile computing stuff? I got a computer on my desk, and that's enough.
I don't know. I was using mobile computing in the early or late 80s, early 90s with things like Palm Pilot and Scion devices.
No, but they're not. Yeah, but that's that. But then they were researching about broadband mobile computing, right? Okay. Transferring high amount of data across the wireless network, and that was totally unheard of back then, right? Just a few years later,
we were all transferring using infrared.
Transferring using infrared, exactly. And we got like 2.5 meter distance limit or something like that. Yeah, but so this thing could become a reality really quickly, guys.
Well, you know what you're talking about, don't you? Like you're talking about Age of the Cylons. That's the reason why I posted the Cylon.
Age of Ultron, you mean?
Cylons. Like, you know what the Cylons are, right, from Battlestar Galactica.
Oh, I see. No, I was thinking of Avengers.
That's what happens. We're going to create an artificial intelligence and then set it up on a quantum computer, and all of a sudden, freaking our own inventions
the world's
are going to
end.
Our own inventions going to turn against us and kill us. Because
right, and that's exactly what the Age of Ultron is, right?
Ultron.
You know. Yeah.
I thought you said Voltron.
No, Age of Ultron. Ultron, the Avengers movie where the robot that Iron Man created suddenly became aware and decided that
humans were obsolete.
Humanity doesn't deserve to live anymore.
That's pretty horrible.
Going back to the sort of Matrix idea, and even further back, Metropolitan.
Yeah.
Well, the Matrix actually has a lot of lore for today when it comes to the tech world. Like, if you really pay attention to those movies, okay, and especially quantum computing, you can see a lot of stuff in there that they're talking about, like the one. You know what I mean? In a computer system, there's no such thing as the one, and he's a variable. You know,
he's the architect.
The architect. No, the architect was an old man. He was the old man, and he created the one as
the one is the programmer.
You know,
isn't it a bit sort of theological, or we could just
it's wishful thinking. I think.
I'm saying
God the one.
I'm saying there's a lot of computer, like.
Well, the brothers that wrote the Matrix, they're computer programmers, weren't they?
You know,
so they make themselves heroes.
Like Tron. You remember Tron, don't you?
The Matrix.
I'm thinking even further back. I'm thinking of Asimov books.
Remember, Tan called you Tron. He said you were Tron, Mark. You're Tron, dude.
That's right. I don't have those sort of light up suits.
He fights for the people.
He's Tron.
He fights for the users. That's exactly what I think of you, Mark. When you know when that phrase comes up, right? Every time it comes up and you defend the user when they're being bullied by the administrators or the moderators.
We call him the man.
Yep. So yep.
You're fighting against the man.
Just fight the system.
That's right. People. See, and then like I know it sounds weird too, but Avatar, okay. I mean, take a look at Avatar. There's a lot of symbolism there too, like the fact that they can take their tails and put it into that beast, and they have that connection.
Yeah.
Okay. Now, you take a look at freaking.
Actually, isn't that based on Gibson's concept, William Gibson's cyberpunk concept?
Maybe it's also very similar to the Matrix.
Yeah.
Well, take a look at like in real life too, with cancer research, where they're taking the cells of rats and they're putting them in human freaking genes, okay, and the cells are actually matching up. Well, that's kind of going into the whole aspect that we're all connected on a cellular level, you know what I mean? And that's kind of what Avatar was getting into when they were doing that, where they would take their tail and stick it into that tail of that beast that they rode. And they would have that conscious connection with one another. It's really weird how that all works out. I mean, there's a lot of things on there that's just it's amazing. And the tree of life, you know what I mean, where they were being put in those pods to be kept alive while their consciousness was being transported out to the avatar, and then he ended up almost dying, and they had to put him underneath that tree to break his consciousness from the frickin' his old body and connect it to the new one. That's pretty intense. So I think a lot of movies are kind of moving towards that. They're getting a lot of influence when it comes to this new technology.
I think a lot of science fictions have now starting to copy each other, even though. So you see the similarity between the different movies, different stories. You know, even Star Trek's the latest Star Trek Picard, where Picard died and they gave him a new robot body. They transfer
arguably that concept of the consciousness goes back even further. It's sort of theologic in representation. Think of the soul.
Oh, the soul. That's a pretty good movie.
Buddhism, the soul gets transferred to, gets reincarnated into another body, doesn't it?
Yeah. Well, yeah. It's a modern incarnation of reincarnation.
The Soul was a trippy ass movie. I'll say that right now. That was probably one of the craziest movies I've ever seen, to be honest. Like, I mean, if you haven't watched it, you need to watch it. It's intense.
Yeah.
I like it, but I didn't even think about it until Mark mentioned it, and I'm not even going to make a comment on Star Trek because Star Trek is just a rip-off of Doctor Who, to be honest.
I watched Doctor Who, and I watched Star Trek. I like Star Trek better.
Well, there's a lot of important material on Star Trek that just coincidentally was on Doctor Who 10 years before.
Yeah. Yes. I kind of agree, but this is the theatrics of Doctor Who is just very
I know.
Ordinary.
I wasn't a big fan of it when I was little, but like when I got older, I grew to appreciate it because like first of all they put it on WPS here in the United States, and that's the channel that you went to watch educational stuff, you know. So
PBS or WPS?
Well, PBS. You're right. That's it. Public Broadcasting.
PBS.
I said, what did I say? WBS?
Yeah, I think that's.
But PBS is where they did it, and I think it would have gotten a better viewing here in the United States if they had put it on regular television.
All right, guys, coming to the hour. I gotta go.
All right. If you guys want to, we can cut this short now.
Yeah.
And
Dinner time.
1 o'clock.
1 a.m. and Mark. Oh my goodness.
Let Mark go to sleep.
And then we have the round table tomorrow.
Yeah, we got the round table tomorrow. I'm gonna do it at 12 o'clock.
Oh my! You gotta do like 6 hours again?
Well, whenever you guys have time to come in, you can come in. You don't have to until you got an open schedule. Now I'll record from the time we get the conversations going. But other than that, it'll just be a stream.
That's cool. You're free.
Have you got an idea? Have you got an idea about the subject matter for tomorrow?
All right.
Okay. Hear it.
No, I'm sorry. Have you got an idea about the subject matter?
Let's hear it.
Oh, he's asking.
Have you got an idea? Yeah.
Well, first of all, I don't really. I don't know how we can avoid about it, but we need to talk about the monetization.
Let's talk about your blow up. Let's start with that.
I will promise you guys that tomorrow I'll talk about it, but I'm not gonna get too deep into it.
Yeah, you're gonna control yourself.
I'm gonna try to be
Civil.
That was a little bit crazy for me. I don't.
Yeah.
There must have been something going on in the background, right? Because it came out of nowhere.
Well, it's just, you know, well, I don't want to get into a rant.
Right.
You know what I mean? So, but
I was actually in the room when you posted that, and I was actually thinking, should I reply to it or should I just leave it to the staff to do something about it?
I think it was good that you were silent, Mark.
I agree.
But yeah, if you guys want to talk about it, we can talk about it tomorrow. And
let's talk about it tomorrow. I mean, I mean,
we can.
It's an elephant in the room, so let's get it out and release it to the wild. Okay, gentlemen, see you tomorrow.
See you later, guys, and thanks for being here tonight.
Bye.
Bye.